Okay, so functions and their inverses. So today we're going to determine whether the inverse of a function is a function or not. And then we're going to, once again, write rules for inverses of functions. Now, we did this back in Chapter 7 a little bit when we were doing, working with logarithms. And so, actually, Lesson 7-2, we did it a little bit. We talked about undoing things when we're finding inverses, and so we'll talk about that again and use that information. So a reminder that when we're finding inverses, that its graph is a reflection across the line y equals x, but the inverse may or may not be a function depending on the graph. So back in Chapter 1, we talked about the vertical line test, which we use the vertical line to determine whether a relation was a function or not. We said that if the graph passes through more than one point vertically, then it would not be a function. Well, the horizontal line test does the same thing except for checking for whether the inverse is a function. Because if we reflected it over the line y equals x, that switches all the x and y values, and so we can use the horizontal line test then to determine whether the inverse is a function or not. So if we look at these two examples here, this one here, the inverse is a function, this one, because I could draw an infinite number of horizontal lines. It'll never intersect more than one point. But this quadratic function here, the inverse of that is not a function because we have horizontal lines that would intersect more than one point at lots of places. So the vertical line test tells us whether a relation is a function or not. The horizontal line test tells us whether the inverse of that function is a function. All right, so we've got two of them here. So if we look at letter A, be the blue line, and we take horizontal line here, and take that horizontal line and we move it up and down, or move it all up and down through here, we can see that it never intersects more than one point for the blue graph. So the inverse of the blue graph would be a function. Now with the red graph, if we look at that one, and we take this horizontal line, we can see that there are many places right here between this max point here and this min point here where the graph, that horizontal line does intersect more than one spot. So the red one, the inverse is not a function. Now another way of looking at that would be to go ahead and do this. Get rid of this. Is that we have this wonderful rotating capabilities on here. And so, and even if you took in your paper or your book and you turned it, if I turn this so that I've replaced the values of x and y, okay, is the blue one a function? Yep, we can see that it is. Is the red one? No, we can see that it's not, because now by turning them, I can see that the blue passes the vertical line test, the red one does not. So you could even do that when you have a question in your book. You can think of it that way also. But you can look at the horizontal line test. It tells you whether the inverse is a function or not. So would this one be a function? Would the inverse of this be a function? Right? We could take the horizontal line, put it anywhere we want, and it's never going to intersect more than one point. So this inverse would be a function. Okay. All right, so there's the most basic part of it right there. Okay. So now we're going to look at finding inverses once again. And when we were talking in lesson 7.2 about finding inverses, we talked about exchanging the value, exchanging x and y, and then solving for y. That was the way we referred to it. Now, we also talked about undoing things. So let's talk about this for just a moment as far as undoing things goes. If I have this function here, cube root of x plus 1, okay? Now, what would you do if you were going to, if I gave you a value to put in there for x, what would you do first? So let's say x equals 3, okay? If x equals 3, okay, what would be the first thing that you would do in finding an answer? Do what? Okay, so the first thing we would do is we would add x and 1, right? Okay, or in this case, 3 plus 1. And then what would be the second thing we would do? Okay, or you would just take your calculator and do the cube root, right? So number 2, then we would calculate the cube root. Okay? Now, and we'll get to my little notes over here in just a second. So this is, if we were going to find the solution there, that's what we would do. So if we're going to find the inverse, okay, if we want to find f inverse of x, then we need to undo those things. Okay? So in other words, we need to work from the bottom back up to the top. So if we're going to undo them, what would we do to undo calculating the cube root? We would cube it, right? So the first thing we're going to do to undo it is we're going to cube the function. Okay? So we are going to, so we'll change x and y around here. Or, no, I'm going to write it this way. Okay? So f inverse of x. Okay? So the first thing we're going to do, we're going to take x and we're going to cube it, right? We're taking our variable and we're cubing it. Okay, undo it. Right? Well, after we cube it then, so we've undone step 2, then we go back to step 1. So how would we undo then? We added 1 here, right? So how would we undo that? Okay, so then we subtract 1. And so there is our inverse. Yep, that's it. Okay. All we did is the operations that we would take to find that problem or to solve that, simplify it, we just undid them to find the inverse. Okay. Well, so we're going to cube our variable. So if we used 3 here, okay, and would have done that, then we would end up with 4, right? So we had cube root of 4. So we would undo that. So let's see what we do here. Let's write it out. So we'd have the cube root of 3 plus 1. Here's our first step right here. So then we would do the cube root of 4, right? Okay. So to undo that then, we would cube the cube root, okay? Which if I cube the cube root, we're going to get 4, right? Because these two, the index and that power, undo each other. So that equals 4. And then I would subtract 1, which would get me back to where I started with 3. Okay. Okay. All right. Now, let's figure out whether this is, we know x cubed minus 1 is a function, though, don't we? Okay. Because they're also asking us to determine whether it's a function and then state its domain and range. Okay. So we found the function. Let me get rid of this. We found the function. Is x cubed minus 1 a function? Yes, it is. So that's why I can write it as f inverse of x. So it is a function. The domain, since it's a function, and it's just a cubic function, right? Okay, so it's a polynomial, so the domain is all real numbers, and the range is all real numbers. And we can graph it to check that. So let's go ahead and make the graph. Reminder, we can do cube root. So if we go to math, it has the cube root there at number 4, and x plus 1. And so here's the graph of the cube root of x. Okay. Does it appear that that passes the horizontal line test? Okay, it does pass the horizontal line test. So then our inverse would also be a function. Now here's the thing. If the inverse is a function, we write it as f inverse of x, using that minus 1. Okay, if it's not a function, then we're just going to say y equals. Okay? Right, and then we can calculate the domain and range. Right. So let's look at this one here. Let's go ahead and look at it together. So when you're doing it, think about what you're doing to get the answer, okay? And then undo that, right? Because we're going to think of it two ways. And then I'm going to go back and show you the way we did it before in lesson 7-2. And then we can talk about that method, because some people might just prefer to use that method to do it. Has everybody got an answer already? Oh, no. Okay. All right. Go ahead. Do you want to try it, or do you want me to do it with you? So let's think about it then. What's the first thing we're going to do? Okay, the first thing we're going to do is we're going to cube x. Okay? And then what's the second thing we're going to do? Subtract 2, right? Okay. So if we undo those things, what will we do first? Not subtract 2, add 2. Right? So the first thing we're going to do is we're going to add 2. And then the second thing we're going to do is, what's the undoing of cubing it would be to do the cube root. So we have the cube root of x plus 2. So we need to determine whether this is going to be a function or not. So we can graph it. So put in my y equals x cubed minus 2. And is that, okay. All right, it is. Okay. So this would be f inverse of x is equal to that. Okay. So it is a function. And what about domain and range in this case then? Okay, they're both all real numbers again. Okay, domain and range are all real numbers. Now, a reminder of what we did before. is that we would exchange x and y and solve for y. Okay? And if you want to use this method, you can use this method too. I kind of like the undoing method. Okay? Okay, what are we doing to get here? Okay, and how can I get back? So, to solve for y, we would add 2 to both sides. That's what we said, right? Because when we said we're going to find the inverse, we're going to undo these things. Step 1, add 2. Right? That's what we did. We added 2. Step 2 then, cube root. Okay. So then we're going to take the cube root. So y equaled the cube root of x plus 2. But since the inverse was a function, we would say f inverse of x is equal to that. Okay, you've seen that inverses of functions are not necessarily functions. So when both a relation and its inverse are functions, the relation is called a one-to-one function. So if we have a one-to-one function, then each y value is paired with exactly one x value. So the 2 we just did, in example 2, those were one-to-one functions because both the function and the inverse were both functions. Well, if they're one-to-one functions, then we can use the fact that by composition, check to see whether they are inverses of each other or not. Because if they're one-to-one functions, then if I put them together by doing composition, they will return just the value of x. Since the reflections over the line y equals x, if I find the composition and they are inverses, then they will simplify to just be that line y equals x. So if the composition of 2 functions equal the input value, the functions are inverses. So we'll check it by doing, we will do f of g of x and g of f of x. If they equal x, they're inverses. If they don't, then they're not. Okay. Yeah. Okay, so here's how it works. You can disprove something by doing it one way, but you have to prove it by doing it both. Okay? So if I do f of g of x and it doesn't simplify to x, then no, they're not inverses. Okay? So let's look at this one graphically first before we actually do the calculations. So we're going to determine by composition whether each of these functions are inverses. I have graphed here f of x equals 3x minus 1. So if we graph the other one, y equals 1/3 x plus 1. So if I graph that then, does it appear that those are inverses? What am I looking for? Whether they're reflections over the line y equals x, right? So let's draw on the line y equals x. Come on. Okay, let's not draw on the line. Let's just draw it ourselves. So the line y equals x. Here's -5, -5. So are those inverses by the graph? The answer is no, because if they were, then they would intersect where? Okay, they'd intersect on the line. Okay, since they don't, we know that they're not inverses. So we're going to prove that using composition. So we're going to do f of g of x. So we're going to take the function g of x and put it in for x and f of x, and then simplify. So we have 3 times the quantity 1/3 x plus 1 minus 1. We distribute the 3. 3 times 1/3 is 1. Plus 3 times 1 is 3 minus 1. So we get x plus 2. Since that does not simplify to x, then these are not inverses. If it did simplify to x, then we would need to do g of f of x also to show that it equals. But once I've disproved it one of the ways, I don't have to do the other. But to prove it, I have to do both.